All right, so in our last video, we looked at equations as functions. So we took things like y equals 2x minus 3, and we talked about how that equation is a function. When we look at that equation, we know that this y is our output, and we know that this x is our input. So remember, we described this as being the function's rule, because it tells me that if I want the output, I need to do 2 times whatever the input is and subtract 3. So this is a rule that tells me exactly how x and y will be related, exactly how x and y will be connected in this particular function. And so what we saw is we could take that rule and we could make a function table, and we could choose some input numbers and use the rule of the function to produce these output numbers, and then we could even graph the function using that information. So if I were to choose -1 as an input value for x, I would plug that in here and get y equals 2 times -1 minus 3, which would be -2 minus 3, which would be -5. So in this function, -1 and -5 are connected. I could use 0 as an input value for x, which would give me y equals 2 times 0 minus 3, which would be 0 minus 3, which would be -3. So for this function, 0 and -3 are connected. I could pick a number like 8 as my input value and do y equals 2 times 8 minus 3, which would be 16 minus 3, which would be 13. So in this particular function, 8 and 13 are connected. So equations can operate as functions. The x in the equation is what we're going to input. The y in the equation is going to be our output. And the function equation itself gives us the rule that tells us exactly how those x's and y's are going to be connected to one another. Now, we are going to take this idea of equations and take it one step further today by talking about something that's called function notation. So equations that represent functions are often written, that doesn't have an S on it, are often written in something called function notation. And function notation kind of hinges on a common way of writing things. So let me show you that real quickly. Function notation kind of hinges on this particular statement. Now this statement's going to look weird to you for a minute, but we'll kind of straighten it all out. Now here's what this statement is saying. It is saying that a function named f, so a function named f, takes an input value x and produces an output value y, which is how we know this operates. Our function equation named f takes an input value that we call x and produces an output value named y. So this notation, when we kind of understand how it's set up, kind of reflects what we already know about these functions. So I want to point out here what you need to know, that f is not a variable. It is actually a name for the function. So don't treat that f like a variable. He's not. He is the name for the function. The x that we see in the parentheses is still our input. X will always be input. And the y will always be our output. So a function named f takes an input named x and produces an output named y. Now, let's talk about how you say this. And there are a couple of different ways. One is definitely simpler than the other. So you would say, when you read this statement right here, a function of x equals y. So you would say a function of x equals y. Or, and this is the shorter way, you can just say f of x equals y. F of x equals y. So we can shorten up a function of and just say f of x equals y. So those are the two ways that we could read that. Now what I do want to point out here, because this is a common mistake, is that this is not f times x equals y. So when you see the f and the parentheses and the x, a lot of people mistake that for multiplication. It is not. This is not f times x. That is f of x is equal to y. Now, here's what I need for you to understand about this statement that I've got written on the board right now. We've talked about what all of this is. The f is a function of, it's the name for the function. The x is the input, and the y is the output. Now, I want you to notice exactly what this statement says. This is really, really important here. This says that f of x and y are exactly the same thing. That's what that equal sign means right there. That f of x and y are exactly the same thing. What that means is they are interchangeable. Because this statement says that f of x and y are equal, it's saying they are the same, they are interchangeable. So how does that affect what we've been doing? Well, here's the answer to that. Let's let y equal 4x plus 1. So this is one of those function equations that we dealt with on Tuesday. This says that if you want the output for this particular function, you will do 4 times whatever the input is and add 1. So this equation describes in this function how x and y get connected, how they get paired. We get the output by doing 4 times the input and adding 1. Now, what we just said over on that other board is that this y that we see right here is the same as f of x. So if I let y equal 4x plus 1 and I know those two things are equal, then I could rewrite this as f of x, a function of x, is equal to 4x plus 1. So because y and f of x were equal to each other, they are interchangeable in problems. So I can replace this y with that f of x that I talked about just a second ago. Now again here, let me kind of emphasize to you what's going on. I want to make sure you understand this. The f that you see right here is the name of this function. So that f is the name. Let me write that down over here. It tells you that this is a function. The x that we see in here is the input. X is always input. And then now, when I look at the other side of this equation, the 4x plus 1 part of this, okay, the 4x plus 1 is the rule that finds the output. So a function of x is equal to 4x plus 1 tells me that if I want to find out what the output is, I input x into this rule 4x plus 1. All right, so if I let, so you might be thinking, why would they do that? Why would they take that y and replace it with that f of x? Because that looks more complicated. And it does. But it will make life easier when they want to do things like this. They could say to you, let f of x equal 4x plus 1, and then say to you, find f of 2. So they could say to you, let f of x equal 4x plus 1, find f of 2. So if f of x, if a function of x is equal to 4 times x plus 1, then a function of 2 should equal 4 times 2 plus 1. Notice the change that I'm making from here to here. I have taken that x inside the parentheses and I have made it a 2. So remember, x is my input. So this number right here is my input. So when it says to find f of 2, what that means is input this 2 for x in the function that's named f. So that's what I did over here. I took this function rule and I input 2 for that x. And so now you would work that out. So you would do 4 times 2 is 8. And then 8 plus 1 is 9. Now I want to point out something here. I want to make sure this is crystal clear. This number right here, the answer that I got, that would be an output. So that number is a y value. So this is telling me that when 2 is my x value in this function, he will connect with a y value of 9. All right, they could say to me, find f of negative 5. Well, if I know that f of x is 4 times x plus 1, then f of negative 5 ought to be 4 times negative 5 plus 1. Because again here, they're replacing this x that I see in my parentheses with negative 5. So they want me to know that negative 5 is my input. So I input negative 5 for x in that function's rule. So 4 times negative 5 is a negative 20, and a negative 20 plus 1 is a negative 19. So f of negative 5 would be negative 19, and that is my output. That is my y value. All right, same function rule. F of x is equal to 4x plus 1. If they said to me, find f of 10, f of x, f of 10, they want x to be 10. So that means input 10 for the x, so 4 times 10 plus 1. That'll be 40 plus 1, which would be 41. Now that 41 is an output value, so that is a y value. So the number in parentheses is your x, and the answer that you get is your output, so it's your y. We could even do this with variables. If they said to you, find f of a, you had f of x up here. Now they're saying f of a. So they want that x to be an a. They want your input to be an a. So you would do 4 times a plus 1. You would input an a where you see x in that function's rule. Now the difference here would be I can't actually work this out. Because when I go to do 4 times a, I have no idea what that is. 4 times a is just 4a plus 1. And I can't do 4a plus 1 because I don't know what 4a is. So 4a plus 1 would be my answer. That would be the best that I could do. Let's do one more. Watch this. They could even on a problem like this say to me, find f of 2x plus 5. So notice what I had up here. I had f of x is equal to 4 times x plus 1. If they say f of 2x plus 5, then this is what they want my input to be. This is what they want me to put in place of this x. So instead of 4 times x plus 1, I'll do 4 times 2x plus 5 plus 1. So whatever you see inside those parentheses, I don't care how complicated it is, that's what you plug in for x in the original function's rule. So you have f of x is equal to 4 times whatever x is plus 1. So if this is what x is, you do 4 times that plus 1. So 4 times 2x plus 5 plus 1. Now to work this out, you would distribute first. So 4 times 2x would be 8x, and 4 times 5 would be 20. And then when I look at 8x plus 20 plus 1, there's really only one thing I can do to that, and that's add the 20 plus 1. So this would be 8x plus 21. I can't go any further than that because I don't know what x is. So when you see f of x, understand that the f is just the name for the function that you're supposed to be using, the function's rule, and the x is your input. Whatever is inside the parentheses is your input. So take the function that has this name and put whatever you see inside of those parentheses in for the x. Input that for the x. Now, I should mention here that while f of x is probably the most common name, you can use other letters. So for example, g of x would also be equal to y. G would be the name for the function, x would be the input. H of x would also be equal to y. So now the function's name is h, this is still the input. P of x would also be equal to y. So p would now be the name for the function, x would still be the input. Now why might you want to do that? Why might you want to be able to use those other letters? Well, they could give you a problem like this. They could give you f of x is equal to 2x minus 1. G of x is equal to x squared plus 5. H of x is equal to the absolute value of 2x minus 1. P of x is equal to, let's do 1 minus 3x. So what I want you to notice is that we currently have in front of us 4 different functions. Each one has a different rule. So in this first function, you're going to do 2 times whatever x is and subtract 1 to get your y value. In this second function, you're going to do x to the second power and add 5 to get your y value. In this third one, you're going to do 2 times x, subtract 1, and then take the absolute value to get what y is. And in the last one, you're going to do 1 minus 3 times whatever x is to get your y value. And what I want you to notice is each one of these functions has a different name. This function's name is f. This function's name is g. This one's is h, and this last one's is p. So they could come over here now and say to you, find g of 4. G of 4. So when they say that, what they're telling you is use the function named g, x squared plus 5, and input 4 for the x. So this is telling me to use the function named g, input 4 for the x. So I'm going to do 4 squared plus 5. So naming the functions different things, using those different letters, allows me to work with multiple functions and not be confused about which one I'm supposed to use. The letter tells me the name of the function to use, and the number in the parentheses tells me what to put in for x. So 4 squared would be 16, and then 16 plus 5 would be 21. So 21 would be my y value. That would be my output. They could come down here and they could say find h of negative 10. Well, I know they want me to use the function named h, so the absolute value of 2x minus 1. And I know for the x, they want me to input negative 10. So I would have the absolute value of 2 times negative 10 minus 1. So that would be negative 20 minus 1, which would be negative 21, which would be a positive 21 in the end. So when I use the function named h, and an input of negative 10, I'm going to get an output or a y value of positive 21. Let's see. I'm going to make myself a little space here and do one more. Let's say I want to do p of negative 5. So that tells me I want to use the function that's named p, so 1 minus 3 times x. And I want to input negative 5 for his x, so that's going to be 1 minus 3 times negative 5. Now be careful on this one, because you know you've got to do this multiplication first. And I need you to see that you're doing a negative 3 times a negative 5. So watch your signs here. It's 1 minus 3, so that's a negative 3, times negative 5. So this would turn into 1 plus 15, which would be 16. So it doesn't matter whether they do f of x, g of x, h of x, p of x. Doesn't matter what letter they choose to use. That first letter is the name of the function, and that will help you determine which one to use. But notice the x inside the parentheses. Whatever you see inside the parentheses, that is your input. So function notation. Function notation gives us a different way to write these equations, and it hinges on the fact that f of x, or g of x, or h of x, whatever, is the same thing as y. So this can replace y, and vice versa, and vice versa. All right, so today you will do some work with function notation. If there are questions, please do not hesitate to let me know, because this is really important stuff we're doing right now. So any questions, let me know. Thanks.